All right, in this example, we have a system of three equations with three variables, and we're going to solve it through elimination instead of substitution. So with elimination, as we've done with two equations, we're just trying to add two equations together to eliminate a variable. Sometimes we need to multiply by a number so that we're able to eliminate. So if we look at this, we can pick a variable that we want to eliminate. So for example, let's say we wanted to try to eliminate the z's here. I'm looking at the first equation and the third equation. The first equation and the third equation are already set up so that if I add those, the z would cancel off. So I'm going to write that over here. 2x plus 3y minus z equals 13. And then x minus y plus z equals 3. So if I add the first and third equation, I would get 3x plus 2y equals 16. So then I have this equation and I eliminated one variable. Well, then what we need to do is eliminate the z with the second equation. So we either have to look at the first, maybe trying to combine the first and second, or maybe the second and third, but we have to use that second equation as well. So if we want to eliminate the z's here, let's say we take the second and we take the third equation. So you can see that the second equation is negative 3z, and the third equation is just 1z. So I'm going to have to multiply that third equation times 3 to set this up. This will be times 3 times 3. So once I multiply that out, the third equation would be 3x minus 3y plus 3z equals 9. And then I'll just write the second equation below it again. Second equation is 3x plus y minus 3z equals 11. So now we can add those and I can eliminate that z. So I'll get 6x minus 2y equals 20. So now I have this equation, and I also have this blue equation over here. So now you can see from doing both of those eliminations, now I'm left with these two equations with two variables. So it actually just goes back to what we did in a previous section. This is now a system with two variables. So now I just have to use elimination again and connect those two equations. We just have to eliminate either the x's or the y's. Well, you can see that we have negative 2y here and we have positive 2y here. So it fits perfectly. It's already set up for elimination if we add those two together. So I'm just going to write it again here. So 3x plus 2y equals 16. I'm going to add together with the 6x minus 2y equals 20. And if we add those, we'll get 9x equals 36. And then we can solve for x and get x equals 4. So we use elimination to try to use a combination of all three of those equations, and we're trying to get rid of one of those variables. In this case, we got rid of z, and then we had to use elimination one more time with our results here with these two equations to get to an actual answer, x equals 4. Now we know what x is, so now we just have to figure out what y and z is. So this part is simply going to be a matter of substituting back into the previous equations that we've used. So I know what x is. I could go ahead and maybe use this equation right here, and I could figure out what y is. I could also use that one right there. It doesn't matter which one I would use. So I'm going to use the 6x minus 2y equals 20. So that means if I know what x is, that would be 6 times 4 minus 2y equals 20. So therefore 24 minus 2y equals 20. and then negative 2y equals, I'm going to subtract 24. That's going to give me a negative 4 on this side, and so y equals 2. So now I know what y is. So I know what x is, I know what y is. So now I need to go ahead and plug that into any one of my original equations. And again, it doesn't matter which one I use. So I'm just going to use this last one right here, because that seems to be the easiest one. So I'm going to take this one right here and get my final answer, or my final z. So we know that x minus y plus z has to be 3. So I know that x is 4. I know that y is 2. I don't know what z is yet, so I'm going to keep that z in there, and then that has to equal 3. So now we should be able to solve for z. So 4 minus 2 is 2, plus z is 3. So therefore, z has to be 1. So now we solve the system. We have our 3 answers. We also have the ordered triple. We could write our answer, if we want, as an x, y, and z triple. So we could write it as 4, comma, y is 2, and the z is 1. So you might see your answer like this, or you could just circle each variable that you found as well. So that's how we use elimination to solve. You can also use it, of course, with substitution. Either one of those methods is going to be just fine.